It is 9:45 a.m. I just spent about 1 hour and 45 minutes on day 1. There is still one thing I want to test, if the conversation history is integrated with Gradio. Do you remember, we added the user input and the system response to the list storing the conversation history? Let's see if it collected the latest interaction. Nope, it did not. I think I forgot to rerun the cell after I updated the function process_input. Let me do it now. Then I need to relaunch the Gradio interface and ask some questions. I first ask for the irrelevant question. System blocked it. Nice. Now, how to create a post. System classified it as relevant. Let's now see the history. Excellent. Everything worked as expected. Hello everyone, welcome on Debugging with KTiPs. If this isn't your first time here, then welcome back. If it is your first time, welcome on board. Today we start the implementation of a 7-day agent challenge. We will code an AI agent from scratch. If you missed the description of this project, please visit the link popping up now. Today we want to code, so let's jump in. I will be working on VS Code. I start with an empty project I called 7-Day Agent Challenge. I will be using ChatGPT as coding assistant, the free plan. Also, I will be recording the time to better estimate how long it takes me to implement the different components. This channel is not just about coding but also about discipline. It is day 1 and it is 8 a.m. as I am starting the coding. The sun raised at 6:36 and will go down at about 7:25 p.m. So let's get started. In this project we will use GPT-OSS 20B as LLM. Served by VLLM. What is VLLM? VLLM is a high-performance library for running large language models efficiently, designed to maximize GPU utilization and reduce latency. It supports features like streaming outputs, memory optimization, and multi-GPU inference to accelerate model deployment at scale. I start by creating a folder I call VLLM Server, where I will set up the VLLM server. I use Docker to start the server. So I create the Docker Compose file for that. If you are not familiar with Docker, you may want to check my other videos on how and why working with Docker. The link will pop up now. In the Docker Compose file, we need to configure the container where VLLM will be running. For that we have to first declare a service. Let's call it VLLM. Then we specify the base image we will use. On Docker Hub, there is a base container prepared for running GPT-OSS. I have good experience with this image, so I am going to search for that. Let's open the browser and search for Docker Hub. In Docker Hub, let's search for VLLM/VLLM OpenAI. We select the first result. Navigate to the Tags tab and search for GPT-OSS. Then I will just copy the name of this image and paste it in my Docker Compose file like so. Then I give the container a name. Let's call it VLLM GPT-OSS. Next we define the command to be run each time the container is started. This container will only be for running VLLM. The Docker image is configured so that the entry point runs VLLM serve. So all we need is to specify the model name, in this case OpenAI/GPT-OSS 20b. Then we fix the GPU utilization to 95%. This is to make sure the model never uses the complete VRAM, as we may want to compute some other stuff on the same GPU. I am going to use a single GPU A100 for this application as it is enough to run GPT-OSS 20b. Next we need to specify the download directory, where the model weights should be loaded. This is important, so we just download the model once, and store them persistently on our system. I will first create the folder to store the weights, let's call it models. Then I specify /models as download directory. Next we define the port to expose the endpoint. We also disable the prefix caching to avoid memory overloading. Then we set the shared memory size to 64 GB, ensuring that large tensors and parallel processes, like PyTorch data loaders, or attention backends, have enough memory space to work properly. Then some limits. These hyperparameters are important to control the memory usage. Next step is to specify the device. We want the Docker container to use NVIDIA as runtime. That is why we set the driver to NVIDIA. Then we can also set a fixed device by giving its ID. This is for the case you work on a server with many GPUs available. The capabilities is a list with GPU as item. Then, in order to make the models folder visible in our Docker container, we need to mount it to the container. You do this by using the key volumes in the Docker Compose file. Its value is a list. But we only want to mount one element. You give the path of the folder or file you want to mount, in our case the folder models we just created. Then followed by a semicolon, you give the path where you want this folder or file to be accessible inside the container. We want it to have the same name. And also the same name we specified as download dir of the VLLM command. Then we map the ports. We want to map the port 8008 of the container to the port 8008 of the host. On my system I am not able to run GPT-OSS if I don't use Triton as VLLM attention backend. So I have to set this like so as well. So it looks good and we have the Docker Compose file ready to use. But before we build it, we need to install Hugging Face CLI, as the VLLM container logs into Hugging Face to download the model weights. And to install Hugging Face CLI we need Python. So let's first install Python. Done. Let us clear the terminal. Let's now install the Hugging Face CLI. It fails. Let us clear the terminal again and try to install in a virtual environment. I do it by running python 3-mvenv. You see the folder has been created, with bin and activate in it. Let us activate the virtual environment now by running source venv bin/activate. Then you will see this venv at the beginning of the command line, meaning that we are now working in the virtual environment. Now let us start the Hugging Face installation again. Now it works. The Hugging Face CLI has been installed successfully and we can now use it to log in. We clear the terminal first. Then with Hugging Face CLI login we log in. We are prompted to enter our token. I have one, so I will just copy and paste it here. If you don't have a token, then register to Hugging Face and request one. The login was successful. So my Docker Compose should work. Let us deactivate the virtual environment and navigate to the folder where we have the Docker Compose.yml file. Here you can see that we are now in the VLLM Server folder. Let us clear the terminal. Then by running docker compose up -d, we can build and start the container. We have a bug, the ports key expects a list. Let's fix it. We need to add a white space here. Let's retry the docker compose up d command. Now the container VLLM GPT-OSS has been created successfully, as well as a default network. It can take some time as it is the first time I am downloading the weights of GPT-OSS 20b. To watch the state of the container while it is running, we can run watch-n1, to say we want the logs to be refreshed each second, and then followed by docker compose logs VLLM, the name of the service we specified during the creation in our docker compose file. You can see that the folder models/OpenAI/GPT-OSS 20b has been created and the model checkpoints are being downloaded. While the container is starting, let's go ahead with the setup of our working environment. Here I will develop the app inside a VS Code dev container. To set it up, I have to define the configurations in the folder .devcontainer. In this folder, let's create the file devcontainer.json. Also the Dockerfile. And the file requirements.txt. Where we will put the Python libraries we will be using. If you want to know more in detail how to set this environment, visit the link popping up now. I am going to start the definition of my Dockerfile. We will use Python Slim as base image. It is the same procedure as before. You visit Docker Hub, search for Python images, and then see the tags. No, it did not select the right link. Let's try again. Again, this is wrong. Now it worked. You can see the Python logo, so we are on the official Python namespace. Then let's navigate to the Tags tab and search for 3.12 Slim. We have to scroll a bit to see the one I want to use. Here it is. Python 3.12 Slim. I just copy it and paste it in my Dockerfile. Now let's define some instructions and commands in our Dockerfile. Here I will not go too deep in detail. But I also have a video on that. The link will pop up now. It is important to set the time zone. For me, Europe/Berlin. Then we copy everything in the folder into our container. And install the libraries we will have in our requirements.txt. With this, we have a minimal setup for our dev container. Let's now go ahead and configure the VS Code related setup of the dev container. You do this in the file devcontainer.json. We start by giving our dev container a name. I will call it, guess what, 7-Day Agent Challenge. Next we define the build section. Here we specify the path of the Dockerfile, the container environment variables, and so on. Now the requirements.txt. I am a big fan of Jupyter notebooks, so I will install all needed to have them running properly in a dev container. IPy kernel. IPython. IPy widgets. And for this project we will use the OpenAI API to interact with the VLLM server. You can interact with the server using Python HTTP requests as well. So that is it. The dev container is ready now. Let us see how far the VLLM server is. I will prompt ChatGPT to ask for a curl request to test if the server is responding. My prompt: I am setting up a VLLM server to run GPT-OSS 20B with Docker. Please provide a curl request to test it. It is available at port 8008. Here is the answer. Let me just copy and paste it in the terminal. It fails. We have to be careful here because our model name is not just GPT-OSS 20B, but it is preceded by the prefix OpenAI/. Remember how we defined it in the Docker Compose file. Let's fix it and retry. And boom! We have a response from the VLLM server. We asked the LLM to explain what VLLM is. And we received a wonderful response back. Let's now clear the terminal again. I keep doing this so you can follow easily. We can now continue with the setup of our dev container. I go to the extensions marketplace of VS Code and search for Jupyter. The first proposition is exactly what I am searching for. I don't want to install it on my computer but only inside my dev container. Therefore, I click on this settings icon and select Add to devcontainer.json. Once it is added, you will see this new entry in the file devcontainer.json. The customizations, then VS Code, then extensions, and inside this key the Jupyter extension we just added. Next I will search for Python. Or better Pylons, as it has Python included. Same procedure, I add it to devcontainer.json. The update is immediately visible in the JSON file. Now I think the dev container is fine for now. I can open my project in the dev container. It is straightforward as I am using a small image as base container. Or maybe because I already had this image locally. This is one of the images I use very often. But to make sure it takes all our configuration, let's rebuild the container. And this may take more time. While the container is building, we can do something else. I will set up ChatGPT to be aware of my goals so it can assist me better. Do you remember this plan? I presented it in the intro video of this challenge. There I explained what we have on the agenda. But to be honest, this is just for the discipline. Some tasks may take more time than planned and some may take less time. We will see as the project evolves. Today we start day 1. Our goal is to build the entry point, where users provide input. And then train a guardrail to decide if the user input is worth being processed by our application. So what I am going to do is to load this file into ChatGPT. Then I will prompt ChatGPT with the context of the application. Namely, we want an application where we simulate the way contents are proposed to users on social media. But in our case, the content should only be about content creation and being successful as a content creator. I want ChatGPT to help with the implementation of day 1. Remember, we want the entry point and the guardrail. I will tell exactly that to ChatGPT. I add telling that I am working in a Jupyter notebook in a VS Code dev container. Let me know, guys. Am I old school? When I start a new project, I always do it in a Jupyter notebook. Once I receive good results, I reorganize then. Is it a bad habit? Anyway, for a beginning, the user can use the command panel in VS Code for the dialog. Then we will train a small Keras model classifying the user input to 0 or 1 depending on if the input is relevant for the application or not. It is a very long prompt, but it is important to set the context. I want ChatGPT to provide the code to train the model in the file guardrail.py. It can simulate the training dataset. For that we need a sample of questions we want to answer to and a sample of irrelevant questions. This is just an example and you can adapt it as you want. For example, if you want the application to only handle questions about a specific product your company is selling, just create the dataset with examples of questions you want your application to answer to, and examples of questions you don't want to process. This is where Keras meets NLP. We will tokenize the plain text training dataset. I want to use the int float/multilingual E5 base. And we'll ask ChatGPT to use it. One thing I also do is to tell ChatGPT about the libraries I have. So it will propose if I need to install more. Now let's go. It is a very long prompt. We provided our plan. We want to train a Keras model for classification. The file guardrail.py should have the code for training. We have access to GPT-5, so I can expect a good answer. It looks good. Let's copy the name of the file and create this file in VS Code. I will put this in the root directory of the project. We can see that we are in the dev container. For example, by checking the terminal, we have this dev container here. I will close this terminal with the outputs of the dev container setup, and open one with bash as entry point. Next, let's see the code ChatGPT just proposed. It starts by importing the relevant dependencies, like TensorFlow and Keras. It assumes that our VLLM server is serving the tokenizer. This is not the case, so we will need to fix this. Then it simulates the dataset. Only 5 examples for each set. This is not enough. We will need more. Let's continue. It computes the embeddings using our tokenizers. What are embeddings? Embeddings are numerical representations of text, images, or other data. Each item is mapped to a vector of numbers. They capture the meaning or context of the data so that similar items are placed closer together in this vector space. This makes it easier for machines to compare, search, and understand relationships between pieces of information. In our application, embeddings are the vectors created from posts, comments, or user inputs so the system can understand their meaning. By comparing embeddings in the vector store, Milvus, the app can quickly find posts or content that are most similar to what a user is asking or interested in. This is how the feed gets personalized, and how the chatbot can answer with context relevant to each user. Then we have the model. But this script will not work in our setting. But here it proposes alternatives. We can also use transformers with sentence transformers to compute the embeddings. And this option is better, and we can do it like so. It also mentions that the dataset is tiny. We will ask it to expand it for us to expect a better generalization. So let's prompt ChatGPT to use sentence transformers and expand the dataset to use 40 examples for each type of user input. Now we have a longer dataset. Also here we simulate for the demo. But if you are working on a real application, you can collect this dataset from your application. Now I will just copy the code and paste it in VS Code. Before we run it, I will change the path where I want to store the trained model. I will add it to the folder where I have the checkpoints of GPT-OSS 20b. This models folder we created earlier. Let's ask ChatGPT to update the code to reflect this. I also ask for the additional libraries. As I see, it uses TensorFlow, but I don't have it installed yet. It proposes to install TensorFlow, sentence transformers, and NumPy. We are not using any GPU in this dev container, so I will just ignore this second instruction. Let's copy these libraries in our requirements.txt file. Then let's install them and see. It looks like it is using an old version of Keras. We can see our sequential model. Very simple with the input layer, one dense layer with 128 neurons and ReLU as the activation function. A dropout. Then another dense layer with 64 neurons. And then the output layer with only one neuron. We want our model to predict a single output. This is the label. So we have here an example of supervised learning. If you don't know what it is, please visit the link appearing now. I have a playlist on machine learning for beginners, where I explain the basics. So in our guardrail we have the training dataset. We define our labels to be 1 for the relevant questions, and 0 for the irrelevant ones. The inputs are the texts. In this case we combine the relevant and the irrelevant questions and their labels into the same dataset. Then we want the training data to be shuffled, randomized, before each epoch. This avoids learning order bias, enables better gradient updates, and prevents overfitting to temporal order. The next step of the training is to encode the texts. We do this because Keras models can't directly understand raw text. You need numeric vector representations of sentences. Using intfloat/multilingual, E5 base turns text into dense semantic embeddings, letting the Keras model learn patterns and relationships across languages. Sentence transformers makes it easy to generate high-quality sentence embeddings that capture semantic meaning for tasks like classification. Now we have a complaint: TensorFlow.Keras could not be resolved. This is actually deprecated, as far as I know, but ChatGPT still uses it. Let us report to ChatGPT. It recommends to reinstall TensorFlow. But this won't fix the problem. I think we should better install tf-keras, so I directly ask it. Let's copy and paste it here to see. Here we have the typical problem of LLM not being updated. So it may need an internet search, as the updates probably happened after the model has been trained, or at least after the training dataset was collected. So it proposes to install Keras only. Now we can run the script. It fails. ChatGPT was not able to find the best practice today. As said, we need to install tf-keras. I will do it now. Let me first update my requirements.txt. Instead of Keras, I install tf-keras. I first uninstall Keras. Then install it together with TensorFlow by running pip install tf-keras. Now the script is ready to run. I launch it. The training is happening now. We have an error. We need to modify our imports to use tf-keras.layer as well. I am not sure here, so I ask ChatGPT. The first try is not convenient for me. I had a typo. It is not tf.keras but tf-keras. Let us copy the updated code and paste it in VS Code. I will also remove TensorFlow from my requirements.txt. To be sure everything is clean, I will uninstall TensorFlow. I will also uninstall tf-keras and reinstall without cache. This way I can be sure the version of TensorFlow I have is pulled from tf-keras. Let's clear the terminals and run the script. Now it looks good. The model is training. It is fast, and after a couple of seconds, the training is done and the model weights saved at VLLM Server /models/guardrail_model.keras. This is the path we specified. By navigating to the corresponding folder, we can see that the model is there. Now that we have the guardrail trained and ready to use, let's go ahead with the entry point. As said, I will start in a Jupyter notebook. So let's prompt ChatGPT to implement a code invoking the command panel of VS Code. And start a conversation with the user. The code should load the guardrail we just trained to classify if the user input is relevant or not. I want the classification in a function I will call process_input. Another function. Chat_with_user. should keep the dialog going and each time the user enters a text. The function should invoke process_input to classify. Then the dialog stops when the user enters queue or quit. Let's see. The code is very simple. It starts by loading the model. The Keras model. Then, this is very important, we load the same embedder as we used for preparing the training dataset. We have to use this same embedder to encode the new input we want to classify. The function process_input expects the text as input, computes embeddings of this text, uses the trained guardrail to predict the most probable class for this new input, and will return the label relevant if the prediction is greater than or equal to 0.5, and irrelevant if not. Chat_with_user uses a while true loop to keep the dialog going. The function just returns the label preceded by the word guardrail. We now need the Jupyter notebook. Let's create it. And call it 7-day challenge.ipend. I can directly add a new code cell. Let's now copy code from ChatGPT and test it. For a while I will not need the terminal, so I can reduce it so you can follow better. It is not recognizing the Python environment. We need to be patient here, or what I sometimes do is to reselect the Python environment. And see, it now looks different. I verify the model path one more time. And it looks fine. Also the sentence transformers. Because sometimes ChatGPT loses the context or the conversation history and may use another one. We want to always verify when we are working this intensive with ChatGPT. I will change the welcome message, and instead of printing this wonderful text, I will add it to the command panel. I can also customize it. I want to display, "Hello, nice to have you here." How can I help you today? Type Q or quit to exit. Before we run this, let's define a variable where we will store the conversation history. I will call it conversation_history and initialize it with an empty list. Then, in chat_with_user, I will keep updating this list. This will be helpful later for the chatbot part of our application. The list should first store the bot welcome message. Then in the while loop, I will store any user input and the corresponding system response, in this case the guardrail response. If we are convinced with the code, we can run it. The first execution takes a while because it first loads the Keras model and the embedder. Here we are. The VS Code command panel has been activated with the welcome message we defined. "Hello, nice to have you here. How can I help you today?" Let us go back to the list of irrelevant sentences and copy one. What is the weather in? I will ask in Berlin. Okay, we forgot to put the system output as the new chatbot message. Let us fix this. This line does not belong here. I will move it to after the guardrail response. And change the message to be the guardrail output. You can already see that it is working. The guardrail can classify as expected. But we can optimize it. Next try. I again copy my question. Ask for the weather in Berlin and boom, the guardrail just blocked it. I can now try a question about content creation, and the guardrail says the question is relevant. Then I press Q to quit the conversation. Ending chat. Goodbye. We can also add the hint on how to end the conversation in the message we send back to the user. Let's test it. It is working as expected. The execution takes some time, I think. Maybe we should refactor the model loading, and just load them once? This is one advantage of working in a Jupyter notebook. Now it is better. We don't want the models to load each time we execute the cell. With this we are almost done with the goal of day 1. It took about 1.5 hours. Let me see if it is possible to disable the VS Code system message. Press Enter or Escape. ChatGPT did not understand my question, and I will not be able to use GPT-5 until 1:30 p.m. As said, I am using the free plan of ChatGPT. Maybe we can test the code ChatGPT provided. No, it looks weird. I will leave it this way for now. Or let us use Gradio as an interface instead of using the command panel. Gradio is a Python library that lets us quickly build and share interactive web interfaces for machine learning models and applications. We install it using pip install Gradio. I also add it to my requirements.txt. We can run it in our Jupyter notebook directly. For this, I start by creating the interface. We import Gradio as gr. And with gr interface, we define the interface. Next, we need to set the variable fn to the function we want to be invoked each time the user enters a text message. For our case, let's set the function to our process_input. The function already expects a text as input, so it should be fine for us. With inputs, you tell Gradio which component should get the input of your function. With gr text box, you define just a text box, as its name indicates. We can set the label. This is the initial message, what we typically call the placeholder. Let's set it to Ask Me Anything. And then with outputs, you tell Gradio what to do with the output of the function. Let's display it in another text box. The label is system response. I want to mention that I am not so familiar with Gradio, so I will be learning how it works during this project. What I know is that you can also set a title. I will just copy the same message we had previously. This Gradio stuff is now an improvisation. You know, When developing apps, you never just do what you initially wanted to. Sometimes you have to add some additional tools or remove some. But I hope we will still be good on time and complete this challenge after 7 days. So the Gradio interface will be replacing the function chat_with_user we had. This means we need to update the function process_input, as this is now the only function we will execute. For instance, we need to update the conversation history there. With this we don't need the function chat_with_user anymore, so I will just remove it. Now let's add a description. This is a kind of header for our frontend. Here I will just type what the system is designed for. Then we add the .q. In Gradio, the queue is like a waiting line. When many users send requests at the same time, Gradio puts them in order and processes them one by one, so the app doesn't crash or get overloaded. Share equals true makes your app accessible on a temporary public link, so others can try it from anywhere. And inline equals true shows the app directly inside your notebook or environment instead of opening in a separate browser tab. Let's try it. It is loading and, boom. We have our frontend designed as we wanted. We have an input text field. Here we type a message. We can test it with a sentence from our training dataset. Let me quickly copy it and ask about the weather in Berlin. Now we have the system response here. I can try with a relevant question. Let's ask how to create a post. The guardrail output classified it as relevant. And we have it here in the Gradio interface. Gradio also generated a link we can share, as we explicitly asked for in the parameters of the launch function. I open it in a new browser so you can see how it looks like. By sending a test, the guardrail blocks it. So that is it for day 1. We have successfully implemented the entry point for the app. We started by using the VS Code command panel, but at some point decided to use Gradio. And also we trained a Keras model to classify the user input. This model will serve us as a guardrail for the whole application, to make sure we only spend resources on computing tasks that are relevant for the application. When the user sends something irrelevant, we will immediately interrupt the process and return a friendly answer to the user telling them we cannot handle their request. I think we can build on top of it. It is 9:45 a.m. I just spent about 1 hour and 45 minutes on day 1. There is still one thing I want to test, if the conversation history is integrated with Gradio. Do you remember, we added the user input and the system response to the list storing the conversation history? Let's see if it collected the latest interaction. Nope, it did not. I think I forgot to rerun the cell after I updated the function process_input. Let me do it now. Then I need to relaunch the Gradio interface. And ask some questions. I first ask for the irrelevant question. System blocked it. Nice. Now, how to create a post. System classified it as relevant. Let's now see the history. Excellent. Everything worked as expected. For day 2 we will use an LLM to extract relevant entities from user input. We will prompt the LLM to return JSON outputs. Remember, at the beginning of this video, we set up a VLLM server serving GPT-OSS. We will use it starting from day 2 till the end of the challenge. Congratulations if you watched till the end. And of course, I will be happy to read what you think about this in the comments section. I will add links in the description to enrich your assets. Thanks for watching, and as always, happy coding and debugging with KTiPs.